welcome you to, I think, our sixth, possibly, webinar. Time is running, but we thank God that we have another opportunity. We have with us Chris Mbogo, and he's going to take us through a very, very pertinent title or topic: the hidden cost of suboptimal lubricant maintenance programs, especially as we look at maintenance in the industry, maintenance in the automotive, in basically any kind of industry. So Lubezine, as we all know, I think just to preempt, is we still continue publishing our magazine every quarter. We do our Loop Post. It's an e-newsletter every month. And currently now we also have our series that is on the YouTube. So you can be able to see what previously we've had, which kind of discussions and conversations we had, by just going to our Lubezine YouTube. So for now, let's welcome Chris. Chris Mbogo has a very, very wide experience over 20 years supporting the industry in maintenance, especially when you talk about maintenance, you're talking also about lubrication. And I think it will be better for him to do justice by, blowing his own trumpet if he has to. Over to you, Chris. Please introduce yourself, and then we can kick it off.
Yeah, thank you, James. Thank you, Miriam. I'm so delighted to be a participant and a guest in this webinar. I'm humbled and I'm joyful for being invited. My name is Chris Mbogo, as introduced, and I'm the founder and CEO of Droplex Industrial. We are a specialty industrial solutions provider, providing specialty solutions to manufacturing plants. And we picked out 3 key solutions that apply to almost all manufacturing plants. And here we are talking of specialty lubrication, where we talk about lubrication, specialty lubricants and lubrication systems. We also handle or support companies with fluid transfer systems and detection systems as well. These are all solutions that apply to majority, I would say almost 80 to 90% of the manufacturing companies there, because most of them have moving equipment and they require lubrication. And on the fluid transfer side, also companies require some form of fluid handling, because they handle fluids at times, maybe 1, 2, and at times very many, depending on the type of industry. And then when it comes to detection systems, we do gas detection systems, because also a lot of majority of the companies also handle different types of gases for their production processes. We started Droplex back in 2006, just about to celebrate 20 years in operation next year in May. And we are glad that we've had a journey, and the journey is just beginning. We are just getting started. We still have a long ways to go, and we are building this brand so that it has an impact in the manufacturing industry all over Africa and even beyond. So that's briefly just about myself and who I represent. I'm a father of 2. We're married to 1 wife, and I enjoy spending time with my family. And I do play golf with my boys whenever we have time, and most of the time, every other weekend, we do get to play and compete. So that's usually a fun time. And just based on my background, I have an engineering background, and I've worked with several companies in the oil industry sector, as well as, so that's Kobil back then, which is now Rubis, as well as Total Energies. And I also worked with General Electric, the transportation division. So quite some experience, but always learning. And there is more that I'll keep learning and be able to share with you. So thank you very much.
Wow, thanks so much. I think That's quite some rich profile. Uh, Over to our topic today. I think when we talk about hidden cost of suboptimal lubricant or lubrication programs, the fundamental aspect first we need to look at is basically if you could briefly describe what could be suboptimal lubrication is. What is suboptimal lubrication?
Okay, so suboptimal lubrication is what I would say that is lubrication that is not meeting the necessary requirements of a machine, and thereby contributing to increased friction, increased heat into the machine, and thereby resulting in failure of components and also stoppage of production because the equipment cannot be used and will require replacement of components. So it's everything around lubrication that does not meet the requirements of a particular machine. That's what in brief I would define as a suboptimal lubrication.
So when we talk about that, there is some hidden costs. What, in your experience, how do you see this aspect, this practice being overlooked in the industry? Because it's an important practice that needs to be taken care of, but we see that the industry is not really taking keen interest. And how do you think, what can you say the practices the industry are undertaking that are ignoring this?
Yeah, thank you for that question. I do believe that it starts from just what we know lubrication is. Lubrication is not what you see. It's usually what happens inside the machine. On the surface, there is very little that you see. You could see a bearing has some grease from the top, or you could look at a gearbox and you can see the level that there is oil inside the gearbox, but that is just what you are able to see. Lubrication in itself is what happens inside the machine. And I do believe that that's where the gap is, because it's not something evident. It's not something that you see right now. It's not, there is the evidence, but it's not something that you see immediately. I always equate it to, for example, what happens to our bodies when we are not working out. It's not something that we actually see immediately, but we get to see the results or the effects later. Or if you keep driving your car without engine oil or servicing and changing your engine oil, that car, even if it's brand new, it could take you 2, 3, 4 years. But at a certain point, you will need to replace that engine. So that is the reason why it tends to be overlooked. Not that it's not important, it's very, very important, but because it's not easy to see the effects immediately, then it's ignored. On the other hand, for example, if it's an equipment that you're looking at, for example, a pump. If a pump is not able to transfer fluid, immediately you change it and you take it out because you can actually see that it's not performing. However, when it comes to lubrication or lubricants, the non-performance is not evident immediately. However, there is damage that is occurring, component wear, there is increased friction, increased temperature. Then a month or 2 months or 6 months later, you get to realize that your machine now has ceased and now it cannot continue production. So it's because the effect is not immediate. And that's why the industry or industry players, be it engineers responsible for maintenance or even including management, they tend to overlook it. That's what I would say pretty much is what causes the overlooking of lubrication, as important as it is.
And how how severe is this problem? Because it's ignored, and that tells me it kind of will come out. And when it comes out, people will try and avoid saying it was lubrication related. But how severe is this problem? What kind of problems do you expect a plant will experience if they ignore this aspect of maintenance?
The severity extreme. I would say it's extreme because it leads to very, very costly failures or stoppages that are very costly to an organization. Let's take a look at a cement plant. A cement plant, you can imagine, is usually almost one line. It doesn't have additional production lines running concurrently as compared to probably in a bottling plant where you may have a plant that has 3, 4, 5 lines that if one line stops, one other line can continue. In a cement plant, if there is a stoppage at the kiln because of damaged support roller bearings or failed or a damaged gap gear, that causes a stoppage, pretty much the plant has stopped. So if you look at a company that whose production is probably a good $200,000 a day, you can look at how quickly that cost can add up within a week or two. So it becomes extremely expensive not to do the right thing. However, that is not usually the case. Usually we get to see these damages much later. You also mentioned about the fact that it's even at the lubrication or ineffective lubrication is what is not attributed at the beginning, but that also is because at times we don't do the proper root cause and failure analysis. And so because we don't do that, we don't attribute it to lubrication. And even when we do the root cause analysis, at times we don't really attribute it to it might be lubrication, but we actually don't see it. We assume that it's the component that's bad, especially if lubrication has been carried out as required, but the correct lubricant is what was not being used. So that means that you'll find a lubricant, you open it, you'll find a component, open it, and yes, it has the grease or it has an oil, but it still failed. So the blame will be, oh, the manufacturer is the one that messed up or gave us a piece of component that was not good. And so we might as well start looking for another manufacturer because these components are not good. Yet the issue is not with the component, but it is with the lubricant. So I would say those are the issues that exist.
So for a plant, a sizable plant has so many equipment,
Mm-hmm.
and majority of the equipment are using lubricants.
Mm-hmm.
Of course, there are programs that you may want to put this equipment on, lubrication programs. Maybe you could shed some light on what kind of lubrication programs can you put for the plants, and then how would you put, is it all the equipment, or how would you pick the critical equipment in a plant that you can basically put them on a program?
Okay, good question there. As regards the criticality, I believe it all depends on the type of plant and what critical means to you. For example, I talked about the cement plant. Let's go back to the cement plant. The kiln is one critical piece of equipment in a cement plant. It is pretty much the heart of the cement plant. And the stoppage of the kiln means stoppage of the plant. The packing and everything, the packing lines, you can have 3, 4 packing machines at the end of the production process, but all the cement material has to pass through the kiln. As such, when the kiln stops, you're dead. So what that means is that if the kiln is critical, that means that all your efforts and resources to make sure that you have the right lubrication practices being focused on the kiln are important, and they must be put in place. And here we are talking about the lubricants, the right lubricants, the lubrication equipment, if you're talking about having automated lubrication systems, as well as the well-trained personnel, because well-trained personnel contribute to whether lubrication is actually being effectively carried out or not. Then you have the second layer. So critical equipment, you may have one, you may have two, you may have five. And like a cement plant has very many critical pieces of equipment, because it's almost like one production line. Some huge cement plants have 2 lines or 3 lines, but generally most, for example, in our region, we have one production line. You have one cement mill, you have one coal mill. So all those are very critical pieces of equipment. And so those ones need critical attention. Then the next level is the secondary, almost like the next level of criticality, where, for example, you're looking at a failure is not something that you'd want. It's a gearbox. Replacing a gearbox that carries maybe about 3,000 liters of oil, or a motor, maybe about a 100 kilowatt motor, that's very costly to replace, or you may not even have a spare for it, as much as it may not be considered in the main production line. However, it's also very critical because of the cost, and then the others. However, it doesn't matter what level of criticality is there with your equipment. I do believe that all equipment is important because there is a cost to it, and the cost is maybe high or low. However, it's still a cost. If you have to replace a small bearing when you shouldn't have, that is a cost. It's an unnecessary cost. So in terms of the priority, I think all the equipment in a manufacturing plant is critical, because it's not like you're getting the components for free. You're spending money. So why not take care of it? You may not require to do, for example, to install different systems like automated lubrication systems on all the equipment, because it's probably it's likely that some equipment are okay being lubricated manually. So those may not require that level of lubrication, where you have an automated lubrication system vis-a-vis the cost of installing an automated lubrication. However, in terms of how critical it is to take care of the equipment, I believe all of them, it's important to take care of the equipment at all times and do the right thing when it comes to lubrication, because there is a cost to it.
Thanks for that insight. Looking at the various condition monitoring techniques that are there, can you say that the best is lubrication condition monitoring, or how do we interact with the other condition monitoring techniques like vibration analysis, thermography? As a plant manager, as a plant engineer, how do we integrate all these? Do we use one, or can we use multiple of them? What advice can you give?
I think it's multiple. Of course, lubrication is not the cure for everything. If you have a misaligned bearing installed, or if you install a bearing incorrectly, it doesn't matter whether you have the Mercedes-Benz of lubricants. It will still not work. That bearing will fail because it's probably too loaded on one side. So there's need for all condition monitoring activities to be carried out, lubrication being one of them. And lubrication actually usually comes out where somebody is able to actually tell that there is probably a high noise level because the lubricant is not performing as it should. Temperature increase is because of at times poor lubrication. But you have to check all those conditions to be able to tell whether lubrication is actually being done well. Sorry. So they are all very important. Lubrication being important, but also using these other condition monitoring activities to confirm that everything is okay. Because all these equipment, whether it's a bearing or components, they are made out there in the industry. There could be a manufacturer's defect. So lubrication cannot be on its own and assume that it will cure everything. It's important to check all this, but lubrication being very critical, especially where you have rotating equipment and the like. Yes.
Great. So I think now we can go to the nutshell. I would like to know more about Droplex, what you do, and then we can have one or two more questions. And for the audience, I've seen Miriam has indicated in the chat. Kindly, you can put up your question in the Q&A section so that when we are done, we should be able to look at those questions and Chris will answer them. But for now, Chris, maybe you can just now tell us more about Droplex, what you do, and then we'll have one or two more questions, then the Q&A, and then we'll be able to wrap up.
Okay. Thank you for that. I think I would rather share the screen a little bit just to help explain or tell people what we do. Is it? Can you view it?
Yes, it is fine.
Okay, so that's myself there and what I'm about. I think I'll start from here a little bit. Over 20 years we talked about. In terms of my philosophy, which will apply now, it will come on the company side. I do believe in going beyond the engineering. And what I mean by going beyond the engineering is not stopping at the component, at the engineered product that you have. It's about what does it do for me or for the organization. Because it's common that you find that we look at products as the solution, but really it goes beyond that. What is it able to do for you? So when it comes to a simple thing as a phone, there are so many phones out there, different models. However, different phones have different capabilities. I know there is at times we do buy phones for style, but also there are some phones that are more suitable for others than others. For example, if you work in a manufacturing company and you're in the maintenance department, I believe having a phone with a very good camera is a good thing because you may need to take good pictures of some components if you need to share it with others. So for you, getting a phone with a very simple camera may not do you that good, because what that means is that there is more to it than just having a phone or a camera. If it's a thermal imaging camera that you have, is it able to show you that an area has higher temperatures than another? Does it show that variation, or it just shows you the temperature is high? So an infrared camera or an infrared thermometer is good enough showing you the temperature is 100 or it's 105 degrees. But a thermal imaging camera will not just show you the temperature, but it will actually show you the area where you actually have that increased temperature. And that's what I mean by going beyond the engineering. Is the person who is using it well trained? Does he know how to optimize a certain solution that has been provided to him or her? So that's what I call going beyond the engineering aspects of a machine. And that's why I say I believe in going beyond the engineering and transforming technical products into measurable performance improvements. So I'm passionate about helping companies thrive in production and maintenance, because production and maintenance go hand in hand. So let's now go to Droplex. this is what we do. We turn engineering into an advantage. We don't stop at saying, oh, we sell a lubricant or we sell a grease pump. What does it do for you? If it doesn't give you an advantage, then we are not really in business. For us, we don't consider just giving you a product as good enough. So we turn engineering into advantage by helping industry unlock measurable, lasting improvements in reliability, efficiency, and safety across the entire plant. And how do we do this? We offer specialty lubrication solutions where you're talking about the lubricants, which are specialty lubricants from our partner in Germany, who's Kluber, as well as the lubrication systems to apply the lubricants. Now, here, this may not be the common setup for everyone. This is more the picture there. You see that is for the cement plant industry or the mining industry. So that's an installation of ours. Then where you have the automated lubrication, doing the lubrication from a drum. The second one is fluid transfer, how we handle or how customers handle fluids in containers, and not just by somebody going and scooping with a bucket or a jug from the IBC tank, but how do we transfer that product from the IBC container, from highly viscous to flammable products. And then we have the last being detection solutions. And how we do it is we make sure that we give you the technical support, we train your team, we make sure that we optimize your the applications. If it's lubrication, we make sure that it's not just you lubricating, but are you lubricating not just with the right product, but the right grease quantity? Because you could just be requiring 5 grams of grease every week. But in general, we see it out there where customers, the only way to tell whether you have pumped enough grease is by pumping until grease comes out of the bearing, in which case that's waste. So that's what we offer manufacturing companies. So beyond the engineering, our vision being empowering every manufacturing company in Africa to thrive with solutions that go beyond the engineering. Yes, we have the engineering product, but do we go further than that to be able to make sure that we are optimizing the solution for you? So how do we do that on a daily basis? Make manufacturing plants more reliable, efficient, and safe through those solutions that go beyond the engineering. And how we achieve this is through technical excellence, continuous support, and lasting partnership. Like that's one of our systems we installed in a cement plant in Rwanda. Those are some of the solutions that we do, and that's how we help manufacturing plants, not just here in Kenya, in the East and Central Africa region, and even at times going as far as West Africa for some to some of our customers. And then those are simply my contacts. I'm easily reached via my phone, by email, or also my LinkedIn profile at Chris Mbogo, and the company details on the right.
How do you, maybe just for the people who are in the industries, there are very many applications that may require these specialized lubricants. And what are the main characteristics that they could be looking at to know that we need to use specialized lubricants in this application or in this equipment?
Good question. And I can summarize it this way. A lubricant's performance depends on the following conditions. Number one, the conditions of the operating equipment. For example, what is the speed of that particular component? What are the environmental conditions? Is it a bearing that is exposed to hot water, steam, or chemicals? That one will definitely affect the type of grease that is applied. High-speed bearings and slow-speed bearings, that does affect, because the viscosity of the grease in the oil will either meet the requirements or slow the bearing or be too light such that the temperature of the bearing may increase. What about the load? The load is also very critical. If you have a highly loaded bearing, you require a grease that has a high viscosity in order to separate the two surfaces. So those are the two, maybe like the three critical conditions, but also there's also the other one is the environmental conditions like temperature, where, for example, if it's a bearing that is operating at 140, 160, 180, 200, 250 degrees centigrade, those temperatures require a different type of grease. And there are greases made for 140. Past that, going to 160, it's a different grease type. 180 could be a polyurea grease. If you go past 200 degrees, you're talking of a PFPE, PTFE type of grease. So those conditions do affect. If you have water contamination, where you don't want a bearing or a grease being washed out, then that means that you have to use a special type of grease to prevent that washout, because if it's being washed out, then there is no lubrication that is taking place during the washout. If you're talking of a gearbox operating at 140 degrees centigrade, you need a type of oil that has a different type of base oil, which you call a polyglycol. So like, for example, with oils, you have mineral, polyalpha olefin, which is synthetic, and also polyglycol oils. So for mineral oils, the temperatures go up to 80. The moment you go past 80 degrees, 90 degrees, then you need a synthetic oil. Then there's now the polyalpha olefin, where it could go to 110, 120 degrees. But then past 120 degrees, now you're in the region of polyglycol type of oils. So depending on your equipment, type of equipment that you have, it's important to make sure that you look at the manual. Most equipment will be very specific in the manual and will say you need to use this type of grease from this manufacturer, this manufacturer, or this manufacturer, or sometimes only one manufacturer has a solution for you. And what that does is that you need to follow that. The manufacturer has done their homework. They have consulted with the OEM and they have come up with that solution. So it's the onus is on you to go ahead and look at the manual. What does the manual say? If you have a bearing or a component that keeps failing, maybe it's a high time you refer to your manual and look at, oh, what does the manufacturer say? It means that I need to use, if it says that you need to use this special grease, then you start looking for it. If you do not have that in your region, contact a specialty lubricants supplier and tell them, I'm looking for this type of grease. Do you have this, or do you have an equivalent that meets this? It could be a calcium-based, a polyurea, or PFPE type of grease based on the requirements, and that's what you need to look out for. So for example, just to talk about Kluber works mainly with OEMs, original equipment manufacturers, and they work with them closely to develop lubricant solutions for their applications. So a manufacturer comes up with a new equipment today and doesn't know what type of grease or oil to use in different component, in a particular component. They call Kluber, and Kluber goes there and they assess the equipment, look at all the conditions that the equipment will be operating in, and they make a recommendation. If they do not have a recommendation because of what they have, they develop a product suitable for that particular application. That's why Kluber is very particular about working with OEMs, and they work mainly with OEMs. And that's why I think also we find ourselves in the manufacturing sector, where if it's the beverage or the cement plants or in the plastics industry, you find most of those manufacturers in their manuals, you will find that they've recommended Kluber, because that grease or oil type recommended has been tested and proven that it actually meets the requirement of that machine. So if you have a Kluber requirement or a special lubricant requirement in your equipment, or you need an audit, talk to us. As in, that's what we do. That's our business. We are not quick to tell you, use this grease, use that. We come, look at your situation, do an audit, and then we discuss with you and come up with a recommendation that will work for you.
Great. Thanks so much. I think, Miriam, over to you for maybe one or two questions, then we wrap up.
Thank you, James and Chris, for that. We have two questions. The first one is, among the different condition monitoring techniques like vibration analysis and lubrication monitoring, which should be done before the other?
I would say all of them need to be done at the same time. For example, you've just installed a new bearing, and mainly this is on critical equipment. It's important to check the alignment of the bearing, or if it's a gearbox that is level, you need to make sure that all the alignments are correct, because if they are not correct, the vibration will increase. The vibration numbers will be higher because there is a misalignment. However, lubrication will also need to be monitored, because once you have confirmed that everything is well aligned, then lubrication will need to be monitored to make sure that, hey, we are operating in the right spot. So, but after vibration, which you can continuously check, lubrication is always good to be checked maybe more frequently, because that's where you want to identify if there is a gap. Because if you have low vibration numbers, but lubrication is not effective, soon your vibration numbers will go up. So you need to make sure that constantly you're monitoring the lubrication. You're making sure that lubrication is not going to be the reason for vibration and thereby increased failed components or failure of components. You need to make sure that lubrication is monitored. But all of them are very important. Vibration, mainly, you want to check it also as frequently as possible, but vibration is one of the things that you make sure that from the beginning it is right. And then you now check, okay, how is the lubrication? Because at times lubrication is not being done. So vibration numbers will continue increasing because lubrication is not being done. Yet you can prevent lubrication, vibration issues with the proper lubrication.
Thank you for that, Chris. The other question is touching on whether a lubricant can be classified as a spare part.
I wouldn't say it's a spare part, but all depends on how an organization will want to classify it. It's mainly considered a consumable. They use it as a consumable because these are things that are being consumed constantly, because you can't really say that you've used 2.57 kgs of this grease. It's either you've removed a kg here or 2 kgs or a gram. It's mainly a consumable. But even if it was considered as a spare part, which I don't know whether there are companies that do that, but let me assume that there are, it would still be okay. The thing is, you would rather have more of the proper lubricant being consumed as a spare as compared to the components being replaced, because one gearbox could be easily $100,000 that it costs you to replace a bearing or to replace a gearbox that has failed. Yet you might actually realize that when it comes to lubricants, you don't even spend $100,000 in a year on lubricants. So it's cheaper spending on lubricants than spending on spare parts. I know we've had this discussion before. What is the cost of lubricants in an organization when it comes to maintenance? On average, it's about 2%, 1.52%. But even let's take it to 3% or 4%. It means that the cost of a lubricant is not the most important aspect that one needs to look at. It's how good of a lubricant am I getting? Am I getting the best lubricant possible? Because even if it's 2, 3, 4, 10 times the cost of what you buy your general purpose grease or oil, it's still much cheaper when it comes to the overall cost of maintenance in a whole year. So when it comes to pricing, to cost of lubricants are not costly at all. Yes, the individual price, you may look at it and say it's 10 times more expensive than these other lubricants that I use, but in the overall cost of maintenance in a year and what a good lubricant saves you when it comes to component costs, downtime, and the like, the cost of lubricants is minimal.
Thank you so much for that, Chris. Those were the only 2 questions we had. So I'll hand it over to you, James, to wrap it up.
Yeah, thanks, Miriam, and thanks, Chris, so much. I think we come to the end of our session this afternoon. First is to thank everyone who is listening through, and we still ask you to subscribe to our YouTube channel that you may be receiving this each and every time that we post. And thanks for the patronage. So I'll give you, Chris, just the parting shot. You can give a parting shot, Chris.
Yes, and I think I've said a lot, but I think the only thing that I would like just to say is effective lubrication is not supposed to be an option. It's the right thing to do. And it affects everyone in an organization, including management. And I think leadership in the industry is not just about the title, but doing the right thing. A good engineer or as a leader in an organization is the one that prevents failures from taking place, from occurring. A good engineer is not the one who runs around the factory fixing broken components or chasing the service technicians to repair things. A good leader, engineering leader, is one who prevents failures from occurring. And it's by doing the right thing, starting with optimal lubrication. Do your lubrication right, and the equipment will thank you. And everyone in the organization will thank you, because for the owners of the organization, they will thank you because they are making more money, because they are saving on maintenance. The production team will thank you because they are meeting their production targets. And the service team will be happy because they don't have to be losing sleep at night because they've been called to come and repair something in the middle of the night, or their weekend, their valuable weekend with their weekends with their family, with their families is being taken up by being called up for emergency repairs. Everyone will thank you. So be a good engineering leader or a plant leader or a plant owner by doing the right thing. Let's do optimal lubrication in our plants, and everyone will be grateful. We'll all thank each other. That's my final parting shot.
Thank you very much. And I'll end with a quote from Chris Mbogo. A good engineering leader is one that does everything to avoid failures from occurring. That's profound. Thanks so much for everyone. Thanks for the opportunity for us to be together. See you next month, towards the end of the month, and may God bless you and have a nice afternoon. Thank you all.
Thank you, and bye-bye. See you next time.
Bye.